Okay, we're now going to focus on, excuse me, one particular type of sequence called arithmetic sequences. And first, just a note about that funny name. This looks like the word arithmetic. It's spelled the same way as arithmetic, but when it's used in this way as a descriptor for sequences in series, we call them arithmetic. So that's a pronunciation thing. Arithmetic sequences. An arithmetic sequence is just a name for a sequence where the pattern in them is very straightforward. The pattern is just that you always add the same amount to get from one term to the next. Let me give you an example. Let's see if we go 3, 5, 7, 9, 11, 13, ... If you think about moving up through this sequence, you start with the first term 3, and then to get to the 5, you add 2. So there's a plus 2 going on there to get from the 3 to the 5. From the 5 to the 7, you also add 2. From the 7 to the 9, you add 2. From the 9 to the 11, you add 2, and etc. All right. In an arithmetic sequence, the sort of key things that you need to focus on, to look at, are you need to know what is the first term. In this case, it's 3. Where do you start? And then you need to know what is this number that you add, this 2 it happens to be in this case. We call that 2 the common difference, because it's the difference between any two terms that are next to each other. If you pick two terms that are next to each other, 9 and 11, and you take their difference, which is the subtraction, 11 minus 9, you'll get 2. So this is called the common difference, and it's often referred to by the letter D. D is our common difference. In an arithmetic sequence, we always have an initial A1 that's given to us. I'm going to make these guys black so they're easier to read. Here we go. Oops. A1 has got to be given to us, so we need to know where to start. And then we have to give the recurrence relation. Since in an arithmetic sequence, every time you move to a new term, you add D, then the recurrence relation looks like this. AN is equal to the previous term, AN minus 1, plus D. So these are, in a arithmetic sequence, these are always true. You can tell me an arithmetic sequence by telling me what the first term is, A1, and then by telling me what the common difference is, D. We also, amazingly, have an explicit... This is a recursive definition. It tells you how to get from one term to the next. But we also have, in the case of these arithmetic sequences, we also have an explicit formula, a general formula for the nth term, which looks like this. AN is equal to, you take the initial term, A1, and then you add D. If we're going up from 1 up to n, you do it n minus 1 many times. So these two boxes are basically all the key formulas about arithmetic sequences. And what you'll notice about them is that this one is recursive. That's sort of the one that we think of most naturally, recursive definition, and this one is the general formula or the explicit formula. Okay. Let's try working with some arithmetic sequences. In this example, 23.11, we're asked to determine if the sequence is an arithmetic sequence, and if so, then find the general formula for it. Okay. Well, let's take a look at A. In fact, I'll just zoom in and write right on the page here. To get from 7 up to 13, we add 6. Oops, too big. To get from 13 to 19, we add 6. To get from 19 to 25, we add 6. To get from 25 to 31, we add 6. This seems to be an arithmetic sequence because every time you jump from one term to another, you add the fixed amount. You add 6. So A, the answer to this is A. Yes, it's an arithmetic sequence. The first term, A1, well, we can look here. A1 is equal to 7. And the common difference, the number that we add each time, is 6, and that's D. So A1 is 7, and D is equal to 6. Now, they say to find a general formula for AN, and we can do this using the formula above. Take a quick peek back at it. The general formula looks like this. A formula for AN is just A1 plus D times n minus 1. Remember, AN can be a formula, it can have numbers in it, and it can have the letter N in it. So this N is going to stay here. We're just going to substitute in the 1 and the D. So here's our general formula. AN is equal to 7 plus the common difference, 6 times n minus 1. First of all, this is a perfectly good formula for the terms of the sequence. But second, we could probably simplify this formula a little bit. Let's simplify it by distributing through and getting rid of these parentheses and multiply 6 by each of these. So this AN is equal to 7 plus 6n minus 6. And then I'm going to combine together the 7 and the negative 6. So this AN is equal to 1 plus 6n. You can test this formula. You can check it by just plugging in some n's and see if you get, for the n's that you plug in, the correct term of the sequence. So, for example, the first term of the sequence is 7. So when I plug n equal 1 into here, that should give me the first term. Let's try A1 is equal to 1 plus 6 times 1, which is equal to 1 plus 6. That's equal to 7. We'll just do one more to check. A2 is 1 plus 6 times 2. 6 times 2 is 12, plus 1 is 13. So this says that A2 is 13. And if we go back and check, we see that the second term, A2, is indeed 13. Okay, I'm satisfied. I'm going to leave this as my boxed answer. This is my answer to part A. This is a general formula for this arithmetic sequence. Let's look at the next one. Okay. So 13 to 9, here we're not adding, we're subtracting, and in fact we're subtracting 4, it looks like. So I'm going to put a minus 4 in between. To get from 13 down to 9, we subtract 4. To get from 9 down to 5, we subtract, once again, 4. 5 down to 1, we subtract 4. If we take 1 and we subtract 4, 1 minus 4 gives us negative 3. So this is also subtract 4 and it gets us to negative 3. And then negative 3 minus 4 gets us to negative 7. So although this one goes down and it also goes into the negatives, nonetheless, it is an arithmetic sequence. So this is our part B. Yes, it's an arithmetic sequence. A1 is equal to 13. And that D, that common difference, is now a negative number. It's negative 4. With those in mind, we can go ahead and substitute and get our general formula. We're going to use the same formula as before. This guy plugging in for A1 and for D. So let's see. AN in general is equal to A1, which is 13. It's not plus, it's going to be, because D is negative, it's going to be minus 4 times n minus 1. This is, first of all, the absolutely correct formula, but we can simplify it a little bit. If we simplify this by distributing the negative 4 through, then we're going to get AN is equal to 13 minus 4n plus 4. And then combining the numbers here, we're going to get that AN is equal to 17 minus 4n. Okay, that's our general formula for the arithmetic sequence given in part B. Okay. Go ahead and try parts C and D on your own, and then come back and we'll do them together. Here we go. So, C. Let's start by just looking at the differences. From 10 up to 13 is plus 3. From 13 up to 16 is plus 3, looking good. From 16 up to 20, however, is plus 4. And then from 20 up to 23 is plus 3 again. Is this an arithmetic sequence? And the answer is no, it is not an arithmetic sequence because of this pesky 4 right there. That's that difference between those two is different than the differences of the other ones, and because of that, not an arithmetic sequence. So this is part C, no. Not an arithmetic sequence. And we're done. We only have to find the general form if it is arithmetic. In fact, it's hard to predict in part C what the next entry is going to be. Will it be another difference of 3 or a difference of 4? Who knows? Okay. Now, part D is a little different once again. It says it's equal to 8n plus 3, and that's a formula for an. And the question is this an arithmetic sequence? Well, let's go ahead and just write down some of the first terms. So this is for part D. A1 is equal to 8 times 1 plus 3, which is 11. A2 is 8 times 2 plus 3, which is 19. A3 is 8 times 3 plus 3, which is 27. A4 is 8 times 4 plus 3, which is 35, ... And if we look at these common differences, from 11 up to 19, we added 8 to get from 11 to 19. From 19 to 27, we added 8. From 27 to 35, we added 8. And so on. It seems that there's a common difference, D, equal to 8. And we also know what the very first element is, which is A1 is equal to 11. So it looks like this is, for part D, it looks like it is an arithmetic sequence. Yes, it's arithmetic. And let's find a general formula for it. Now look, they've given us a general formula for it. But if we use the formula for arithmetic sequences, this is a great confirmation. We should end up with the same result that we have over here. So let's just try. We're going to use the formula that says it's equal to A1. A1 was 11 plus D, which is 8, times n minus 1. So here's our general form. An is equal to 11 plus 8 times n minus 1. That does not look exactly like this. This says An is equal to 8n plus 3. But also this can be simplified a little bit. So let's simplify it and we'll see what we come up with. An is equal to 11 plus 8n minus 8. And then combining the 11 minus the 8 gives us that An is equal to 3 plus 8n. And of course, that's the same as An equal to, we could write that addition in the other order, 8n plus 3, means the same thing. And that is exactly what they gave us in the beginning. So you can see here that after verifying it's arithmetic and plugging it into the formula, we see that we do get the same formula as before. That's a nice confirmation. Okay, that's our initial working with arithmetic sequences. We're going to see how far we can push it with these arithmetic guys in our subsequent videos.